A blessed day to everyone. So today I will going to discuss about how the video signal generated. So the video signal contain high frequencies and they used coaxial cable to transmit and receive signals. The cable connecting the circuits has characteristics impedance of 75 ohms. To prevent reflections which cause distortion and ghosting, the input and output circuit impedance must match 75 ohms cable. So, the purpose of video signal is that an electrical signal designed to produce an image. It is formed by photoelectric converters, a super orticon or vidicon in television, or a photoelectric cell or photomultiplier and picture transmission, or by the detections of electric-magnetic wave received by the radar set. Generating the video signal. The video signal is most often generated by a TV camera, a very sophisticated electronic device that incorporates lenses and light-sensitive transducers to convert the scene or object to be viewed in an electrical signal that modulates a carrier. In order to convert them into electrical signals, the scene to be transmitted is collected and focused by a lens upon a light-sensitive imaging device. Both vacuum and semiconductor devices are used for converting the light information into an electrical signal. The scene is divided into smaller segments that can be transmitted serially over a period of time. The camera subdivides the scene in an orderly manner so that an acceptable signal is developed. This subdivision process is known as scanning. So, what is scanning? Scanning is a technique that divides a rectangular scene into individual lines. The standard TV scene dimensions have an aspect ratio of 4:3. That is the scene within 4 units for every 3 units of height. To create a picture, the scene is subdivided into many fine horizontal lines called scan lines. So, each line represents a very narrow portion of light variations in the scene. The greater the number of scan lines, the higher the resolution and the greater the detail that can be observed. US TV standards call for the scene to be divided into a maximum of 255 horizontal lines. The TV camera connects the scene into an electrical signal by transmitting a voltage of 1 volts for black and 0 volts for white. The electrical signal divide from each scan line are referred to as the video signal. The shades of gray are represented by some voltage level between the 0 and 1 volts extremes represented by white and black. The resulting signal is known as the brightness or luminance signal and is usually defined by Y. One complete scanning of the scene is called a field. Interlaced scanning is used to reduce flicker. The resolution of the TV picture refers to the amount of detail that can be shown. Pictures with high resolution have excellent definition. A picture lacking details looks softer and somewhat out of focus. The bandwidth of a video system determines the resolution. The detailed that bandwidth, the greater the amount of definition and detail. Color signal generation. The color detail is the scene is represented by dividing the light in each scan line into 3 separate signals each representing one of the three primary light colors, red, green, or blue. The light in any scene also divided into its three basic color components by passing the light through red, green, and blue filters. The result is the generation of three simultaneous signals, R, G, and B, during the scanning process by the light-sensitive imaging devices. The RGB signal also contains the basic brightness or luminance information. The color signals must be transmitted with the luminance and the formation in the same bandwidth allotted to the TV signal. This is done by the frequency divisions multiplexing technique that combines the three color signals and I and Q color signals. This is how the video signal generated.